All right, folks, I'm going to show you one more video here, and I'm going to walk through the remaining two examples from section 4.4. So we're on page 26 of section 4.4. These are the two examples that we didn't do the other day. You may or may not have already done them. Your quiz on Thursday, not Wednesday, Thursday will cover section 4.4. So again, if you have questions on this, you can ask me on Wednesday in class, but I want to walk through this so that you can have these examples to continue working and studying. So let's jump into our first one here. The first one is definitely our harder one. So our temptation on this particular inequality is to cross multiply. If we cross multiply, it's going to eliminate the fractions. And the problem with eliminating the fractions is that it means that it also eliminates these denominators, which is where our vertical asymptotes appear. So although there are some techniques and some shortcuts to get around it, I am going to suggest that you just go the long way, and we're going to move this fraction to the left-hand side and just work with our fractions. It'll just keep everything in that rational form so we won't forget that we have vertical asymptotes to consider. So we'll have our 5 over x minus 3, and we're going to have minus our 3 over our x plus 7. That, of course, is going to be less than 0. Now, what we want to do is we want to get common denominators. So the first fraction is going to get multiplied top and bottom by x plus 7. The second fraction is going to get multiplied top and bottom by x minus 3. And then I'm going to do one other thing to really make sure that I don't make a mistake, is that I'm going to change this to a plus, and I'm going to write that negative up top. That's going to help me remember to actually distribute a negative 3 to each term there. Now I can continue pulling these together, so I'll have a 5x plus a 35 and a minus a 3x plus a 9, and that's all over my x plus 7 and my x minus 3, and that's less than 0. Now continue cleaning this up. We'll have a 2x plus a 44 all over x plus 7 and x minus 3, less than 0. Now that we have this, we can set up a number line. And the first thing I like to put on the number line are my vertical asymptotes that will always, always, always be open circles. So I'm going to have a negative 7 and a positive 3, and those have to be open circles. And I even sometimes will label these VA to remind myself why those were open circles. The next thing, since I have this as a single expression, I can find my x-intercept, and I can mentally set this numerator equal to 0, and I can get my x-intercept of a negative 22. And I need to decide whether this should be open or closed. So I'm going to look at the inequality I'm working with, and since it's not inclusive, I'm going to make this an open circle. And you could label this the 0 if you want. Now I'm going to start testing each of my intervals. I'm just going to pick numbers, and I'm going to determine whether the fraction turns out to be positive or negative. So, for example, if I choose a negative 23 and I plug it into the numerator and the denominator, I would get my signs to be a negative over a negative and a negative. So I have a negative over a positive. That's going to be negative. I am specifically looking on this inequality for where things are less than 0. So this is an interval that I want. Moving to the next one, I'm going to pick negative 8. So if I put a negative 8, I get a positive, and I get a negative, and a negative. So now I have positive over positive. That's going to give me a positive number, so this whole interval fails. Then I'm going to plug in my 0 for the next interval, and I'm going to get a positive, and I'm going to get a positive and a negative, and I can see that that interval is going to be negative now, so that's one that I want. The last one is going to be positive, positive, and positive, and that would give me a positive for that interval, and I don't want the positives this time, so that one gets rejected. So my final answer would be this interval and this interval. So I can write that in my interval notation, negative infinity to negative 22, and I join that with my negative 7 to my 3. Okay, that's for our rational functions. Now for the polynomials, those are going to be easier because we can just do a quick little sketch. So on this one, honestly, the trickiest part here is that our r of x needs to go on the left-hand side and the c of x needs to go on the right-hand side. Personally, I think that's the trickiest part on this, is just reading it carefully. So I'm going to have a 2 minus an x squared greater than or equal to my x to the 4th. So I'm going to move everything to the right-hand side so I can keep my leading coefficient positive. Now this often looks like something that we're not sure how to factor, but this is actually called a quadratic pattern. Okay, so it kind of looks like a quadratic, but we can see that our exponents are off. So what we're going to do is we're just going to think about this as if it was a quadratic. So we're going to think, what would we do if the problem had actually looked like a true quadratic? And we would have factored that as an x plus 2 and an x minus 1. And then we literally just go back and then we fix the exponents so they're what we wanted them to be. That's all we're going to do. So then we can fill in the rest of the inequality sign and we can continue working. So we can see that this is going to give us imaginary solutions. This is going to give us x-intercepts of plus or minus 1. So now we can make a number line. We're going to think about making a quick little Gretch of this. So we have our x-intercepts of negative 1 and positive 1. If we even want to put in the y-axis, we can. We can see from this polynomial that the y-intercept should be a negative 2. It is a degree 4 with a positive leading coefficient. So we know these are going to go up. This is just going to come down and go through. And there we are. Now we can go ahead and look at what inequality we're working with. And we can find that. So we are wanting to find, where is this polynomial less than 0? In other words, it's under the x-axis right here. So our final answer is this interval of numbers. I'm going to also notice that my inequality is inclusive, so I am going to use my brackets. So, whoops, sorry. Sorry, guys. Yay, you got to see me erase something while I was in class. Sorry. Okay, then my final answer is negative 1, 2, 1. Okay, again, if those are still seeming hard to you, just pop in to see me or just let's talk on Wednesday. All right. Have a good rest of your day and let me know if you need anything.